recording. So have this. The green means it's working. Let's talk into it. All right. What are you guys?
Which camera are we? Oh, we're on that one. Hello. So I'm Bradley, and
I'm Fred.
Hi, Fred.
that's John. Uh, so we're here to talk about the ISTS game. We made the ISTS game for um, eh, yeah, for this past ISTS, and we're gonna talk about a little bit about the technologies we use to make it. There's some really cool new things that you might learn, especially after watching last week's advanced web presentation. All right, so the game itself, it's divided into basically three different sections. This is a component that runs alongside the ISTS competition, and it can be semi-influenced by the actual infra. This year, it was cyberpunk themed. Thank you, Dan. And so essentially what happened is the map was divided up into territories for each team. And teams could battle each other with troops that they gain over the course of the competition. There's an in-game currency where you can purchase troops and other things at the shop, such as hiring a red team member, rebooting a box, etc. And then also on all the boxes, there were tokens. So purple team tokens, Koth tokens, and sponsors could give out tokens as well. And those could be redeemable in the shop for currency. So this is what the map looked like. So I did the front end, Fred did the back end. And yeah, so this is the map where you can interact with battles, and then the shop. This is the shop where at the top you can redeem tokens, and then you can also purchase. Another cool little feature is on the right hand side, you can actually transfer money over to different teams. So let's say, red team wants to ransom your system, say, hey, send us a bunch of money. Well, then there you go. So how do we make the front end? So React.js, I mentioned this last week a little bit. So this is my primary web framework that I like to use. It's a single page application framework, which is you write in JavaScript. Everything on the web page is served as a single file. Like there's no navigating between different HTML files, etc. Everything is served there and dynamically shown with JavaScript. The benefits, you can have real-time UI updates, and you don't have to use jQuery. And then you can also write HTML in JavaScript and or TypeScript. So a React.js project kind of looks like this. So you have a public folder, and you just have an index.html file. All you need to do is just put a div in there. That's it. That's all you need to do. You can configure, CSS files, whatever else you want, import like Google Fonts, Bootstrap, whatever you want to do. You can do that in there. And then you're going to have an index file. This is where you just render your components. I'll get into what components are in just a second. You're going to have a main app component that gets rendered, and then all your other components that make up the project. So what are components? Well, basically a React project is broken up into visual pieces of the website. So let's say I have a nav, a footer, main content. I have a left column, right column, whatever I want. Let's say I have a generic card. These are designed to be reusable pieces of your website. So if I have a gallery, I can make a component for an image card, and I can show that 15 times. That's really the design pattern that React uses. Is you need to build reusable components that are used multiple places on your site. Otherwise, there's no point in using them because you're not going to reuse them. So you might as well just type it out manually. They each have individual state management, so that's a good feature. You can manage data individually within each, and you don't have to manage it at the highest level, although you can do that if you would like. Um, you can make these components in two different ways. You can use JavaScript classes, or you can use functional, which is kind of the newer, cleaner style. So a class component in React looks something like this. It's kind of just a lot to look at. When I started with React, I used class components all the time because I thought, they're more structured. They got, it's a lot better. And that's probably because I came from like a Java background. That's where I started. So, I wanted to make my JavaScript look like Java. But that's not really what JavaScript is all about. Nowadays, we get to use functional components and React hooks, which are a brand new feature of React. And so, as you can see, it's a lot less code, and we can just return HTML from our function, and React. We don't have to worry about it. React figures it all out. And then here's what it looks like rendering. All you have to do is at the top. That's all my index.html file is, and then we just tell it to render in that root div, and then done. It takes care of it for us. So with React, you can use JavaScript or TypeScript. I actually haven't used TypeScript before this year. And I was always apprehensive about it because it's like a Microsoft product. It seems like it was really confusing and complicated. But actually, it turns out it's really nice. JavaScript is a dynamically typed language that can lead to very confusing debugging all the time. And it's just-in-time compiled most of the time. You can compile JavaScript. Use JS, and JSX is when you have your HTML inside of it. But TypeScript, it's a strongly typed language, as in the name. So it brings automatic type checking into JavaScript, which is really super nice. And so this is compiled. It can be compiled into multiple different versions of JavaScript for compatibility reasons. Also, it plays very, very nicely with VS Code. Of course, Microsoft uses the TS and TSX extensions. Packages are also another big part of React. You don't have to make everything for your website. I can guarantee you, if you want something on your website that is not super, super like niche, it's probably out there on NPM. Just look up React whatever and NPM. It's most definitely there's going to be a package that exists. You can also develop these packages. All you have to do is like develop a component and then put it on NPM, and tons of people will download it. But there's a bunch of these things. Material UI and Bootstrap are big ones. They provide a ton of components pre-built for you. It's nice because you don't have to build everything from scratch, but it does grow your node modules folder, and it leads to larger compiled bundles. Webpack. This is a part of a tool that I will get into, I think, on the next slide. But when you're starting your own React project from scratch, you can use Webpack. This takes all of your multiple JavaScript files and HTML files and CSS files, and it will combine them into a single for each, or a few of them if you do code splitting. But there's a bunch of configuration options that you can do. You can do lazy loading, code splitting, versioning, etc. Go on. And there's also modules for Webpack as well, available through NPM. This allows for like different file imports. So like if you want Sass compatibility, you install Node Sass and then tell Webpack, hey, you need to take all the Sass files and hand them to Node Sass. That they understand what to do with it. So this tool, Create React App, is developed to basically scaffold React projects. It contains a bunch of pre-built scripts. You don't have to manage Webpack configurations. You don't have to do et cetera, et cetera. It gives you a blank React app to start with, and you just start writing React code. That's it. You don't have to worry about configurations or anything like that. However, you do have less granular control over the project. So if I want to configure my Webpack to provide a more efficient bundle, because if you write a very large app and you're just using create React apps default configurations, when someone loads your website, they're going to be loading a lot of code, and it's going to be a little slow to render. So if you want more configurations, you can do something called ejecting the app, which then gets rid of create React app and then just allows you to control everything on your own. And here's some resources to learn a little bit more about React. I highly recommend it. It is a very valuable tool to have in this day and age. Everyone who's anything in the tech world is looking for web people, and they're actually hiring incompetent web people, so you can be the non-incompetent one and go out there and make really great looking websites. Got it?
Yep. So that's the front end side. We have the back end, which was its whole other beast. So for the back end, what we used Go actually. I just been coding a lot in Go recently, and I was like, might as well do this too. And nice thing about Go, it's easy to read compared to, like, for example, like C. And it compiles to like native binaries for like Mac OS, Windows, and Linux, which is nice. It's high performance, and it's also easy to multi-thread things. Like if you use Go functions. I forget the exact name. And then also, it just has a cute mascot, just in general. And it's used in a lot of big projects, as you will see. So, quick overview of a Go project structure. Normally, there's like a package folder, which you would put all like the different libraries that you made. There would be a CMD folder, which you would put like your main.go for actually like running things. Then you'd have a bin folder where you put compiled binaries. I don't really do that. It's a lot, and it's not necessarily required. So instead, what I do go mod init, which automatically creates the Go mod and sum files, which basically, when you do go get for a package, it would write to go mod which package your module uses, and then to go sum the package like hash and what it uses. So when someone else like pulls down and uses your things, you basically get the ones that you used, which is great. Then in this project, we had server.go, which basically was in the root directory. That's kind of like main.go. That's where the main function was, and the main package was defined. Then we have like 3 important folders, which was ent, GraphQL, and logic. So ent, as we're going to talk about, was basically the backend and like the database driver. GraphQL was what we used for the API. And the logic folder is where I actually put the game logic in. So before that also, in server.go, there was Gin, or Go, or Gin Jonic. I don't know how to say the last part. But it's basically a web server in Go, like besides the default HTTP, like net/HTTP server, and it's really nice. It's fast. It's easy to extend. Like you could easily create middleware, which when you're doing stuff, when you're adding stuff, like I'll show you, it is a requirement. And so making simple middleware is great. Another nice thing is even if an HTTP request like basically crashes the server, causes a panic while the process is running, it doesn't just crash your whole binary. It just keeps going, which is really nice when, for example, on our web app, we were using a SQLite file as our database backend. And that caused issues, because that caused locking, because we had a lot of requests, like a lot. So one of the great things with Gin, it just kept going. It just kept, like you would have seen the panic happen in the logs, but it kept going and kept working for everyone else. And I was really surprised how well it held up during the competition, because we may or may not have necessarily done the best job at pulling data from it. So like every second, there were like a few hundred, there's a lot. There's like, Scrollball kept going during the whole competition, and the server itself never like died on us, which was great. So, and they also have like pretty robust documentation, and there are middleware, like there's a contrib where there's a lot of middleware already installed, like for example, for cores, which is required if you want to do GraphQL with the Apollo client, you need cores, otherwise it won't work. And cores, if you have or have not used it, is a pain in the butt from experience.
Go check out the advanced web presentation from last week to find out more.
So this is a quick example of the Gin. This is the middleware we actually used for the GraphQL server. So in it, since we needed to initialize our end client, which is basically database connections, we needed to have like a separate middleware to initialize it. So basically what we do is we create the function, put like and just return the handler function with what we needed to have and what else. So as you can see, yeah, on the top over here, it's as simple as the GraphQL library came with a thing to create a function. So just over here, and then we just return the context with serving the HTTP itself. And then when you're actually creating the GraphQL server, you just basically create this function. Like you call the function, you create a thing, and then when you're using it in queries, like in defining endpoints, you just define that as the function. So if anyone goes to that query, it goes to that function. And one nice thing is if you want multiple middlewares to kind of like, to all cascade together, like one onto the other, onto the other, onto the other, you can. So you're able to do some nice customization and functionality things.
Oh, we have middleware there.
Yeah.
Talk about that.
So over here, this is another middleware that we did, which was for authentication, which basically happened on all routes. And I'll show you the actual code for that during the demo. But it's basically, so you have that middleware on the whole route, and then you had this, the GraphQL handler middleware, specifically on the /query route. And then you just do router.1 run, and you have a working Gin server. Next is Ent. Ent is basically a database ORM built by Facebook, but instead of defining things like as database like specific, you define it as graphs and nodes in a graph. And in each node, it could have different fields inside of it. So like, and then you could easily define connections to other nodes in GraphQL, in Ent. And it's really nice because once you define the schema itself, you just do basically go generate inside the Ent folder, and it builds everything else that would be required to actually query and work with the database, and it's great. And it has some pretty nice documentation, though there are features that are present in Ent that are unfortunately undocumented. So that is unfortunate, but as with everything, that's going to happen. But for example, the feature that I needed that was undocumented was there's a feature which will pool all your database query like requests together and then send them in one chunk instead of sending each individual one to the backend at the same time, which can cause your database to lock up or just be overwhelmed with requests, even if you're using a real database like Postgres and not just SQLite. So the way you work with ent is very easy. You just do go get like ent.go.io slash whatever, slash ent probably. And then once you have it installed, you go to your project's root directory, and if you do ent init, it will actually create the ent folder and the schema folder with basically the package that in this case is example, and then the placeholder for it. And then over here, so there are fields and there's edges. So in fields, that's where you would statically define the actual, like, for example, name would be a string, costs would be integer, what have you. And then in edges, you would actually define the connections to other things. Like, for example, in the game, we had a user, but then a user was connected to an army, which would be used for battle. And then basically GQLGen, which is a GraphQL server implementation in Golang. Also has pretty good documentation. And for simple things, you could basically get up and running pretty quickly. And another nice thing about it, it has compatibility with ent, like kind of out of the box. Like you have to install another package, but basically the compatibility is already there. And if you search it on ent's documentation site, just do GraphQL or GQLGen. Basically, it will give you the exact steps that you need to run to connect your GraphQL server and your ent database together and be able to just use it. It's nice. And so now I'm just going to show you some of the code. So just give us one moment. We were going to public it. We were going to release it at one point, so it's fine.
Just say leaks anyway.
There haven't been any leaks, though.
Oh, there it is.
There it is.
There's the leak.
That's been there this whole time, so.
You asked for the leaks, I give the leaks.
This isn't the vote. Release the vote.
Release the vote.
Hashtag keyboard resistance. What would you do for a Mac Mini?
That's
Is that what you didn't use for like 2 weeks for? I got another one. You bought another one.
Why did you get another one?
What are you doing with all this? This man has a problem. He's an addict. He's a fiend. You know, Emmanuel, if you have all this money to throw away, I'll take it.
That's what I said.
Can I see it on stream?
Yeah.
Probably want to make it a little bit bigger.
Just say that it did. Just say that it did.
Okay.
Whoa.
Just let it
So,
go.
That's a lot of go line.
yes.
Luckily, most of it's auto-generated.
Yes. Speaking of that, it is. So first things first, I will show you in schema.go. Oh, we can enhance even more.
Enhance.
Is that good enough enhancement?
Enhance.
Okay, perfect. Well, so this is in schema.go. This is what we use to define the armies. So like I was talking about before, we have fields over here. So we have 3 fields in here, which was the amount of troops you had, the amount of public troops which you had, which was basically at the start of the round that would be set. So while you're playing the game, other competitors couldn't see what you're actually doing with your troops. And then how much balance you have, which would also be set at the start of the round. So they don't know if you've been spending money or stuff like that. So just there. And then over here, we have the actual edges, which connected to other parts in this graph. So in this case, we have an edge from user. And I'll show you user, how that relates. So an edge from user, which is referenced back here, and the unique keyword makes it a one-to-many relationship. Well, one on this side, and if the unique keyword is not on the other side, it becomes a many relationship. And the required thing is if that edge is not present, then you can't actually create the object. So just validation checking here and there. And then two edges which go to battles, which basically what did you fight, what battles were you in, and like which ones did you initiate. And then, like I said, I'd go show you the users. So in user,
Double click. Big leagues.
there we go. In user, we have the username, password, the balance, the win-loss ratio, and the role, basically just white team, black team, blue teams, red team, just to keep track of it that way. And then over here, you see everything that's kind of related to the store itself, so the purchases, the redemptions, when you're transferring to someone, transferring from someone. And then over here, you see the Army Edge, which also has the unique keyword, which makes it a one-to-one relationship between the two. And then tokens, but without the keyword, unique keyword, which makes it a many-to-blank relationship. And then if I'm just double check, pretty sure it's a many-to-one relationship.
I have the GraphQL up there.
Yeah. So basically, that's defining it in Ent. And then once you do that, you just run go generate in the folder, and then it generates everything that is required. So from battle, it would have like this, which is fun. And then it has like these where statements, and then even more down here, how to create the stuff. And then one nice thing about Ent also is, for example, these generated statements, if there's like something not here, like if you need something that's you don't want in the database, but you want it to be present in the struct, you could actually modify the template which generates this, because basically this just uses the Go text template to like fill everything in. So you could create your own template and just add additional fields if you required it. For another project, I had to do that. It was fun. And then, so that's kind of like how Ent looks. And then we have this GraphQL, which over here, basically you see everything is the same, named the same way as it was in Ent. And using the package that EntGo provides, you're able to basically easily link the two, and things that don't have the same name or are subqueries, it will ask you to create those functions. Like, for example, for ID, troops, and public troops, and balance, I did not have to create any like additional functions for that data to be pulled. But for user, attack battle, defend battles, and battles, I did have to. And another interesting thing is you could add fields that don't exist inside your Ent structure into your GraphQL structure, and just define the custom functions for that. Like, for example, battles in this case. And then once you run go generate, it would do like, it will generate this module then, which will take care of some of the stuff. And then over here in generate.go, have all of this fun complexity that you don't have to worry about. Yeah. And then basically it will generate the schema.resolvers.go file, which you would actually write the functionality for the different endpoints you write. Oh, also, these are just defining like different types. At the bottom, you would define for the different queries you could actually pull from this endpoint. So, for example, get army, where you would pass in an ID, it would return an army struct. And then once we go to schema resolvers.go, command effort.
Yeah.
Get,
You hit caps.
I realized. Get army it generates this function. It regularly generates it with a panic and like error not implemented, but obviously it's implemented in this case. And what it does, it queries the database where the army ID equals the passed in, and it only looks for one return value. If there are multiple armies with that ID, it will error out. If there's nothing found, it will error out. Otherwise, it will return with the army.
And this is all, these all are say that they're all auto-generated functions.
Yeah, and like all these, basically from after client, once I realized moved, okay, remove to users, whatever. So anything after client, all of this are generated, auto-generated functions like by end that you could just, that you use once you create your schema definitions. And then over here, since I'm using GraphQL, I need to actually pass in the end client, which is what's actually used to create the database. And if you look from before, in the server.go, over here, that's what this middleware over here is for, is it actually generates a, it generates the client and adds it to the GraphQL server. So once you're in the GraphQL server, you could just call it from here. And the way it does that is initializes through resolver, which is another like thing which is auto-generated. But if you needed custom, like I did, you just do it this way. So basically, you define the struct and how you do the new schema, and it will basically generate, add the client to your resolver, and then you can use it in your functions and then return stuff. And yeah, I think I'm gonna end it there. There's a lot to go. Like for example, this is like for purchases. When I was telling you, there were other, like when you connect to other nodes, you'll have like these and then these different resolvers for different things. So in this case, in the purchase function, we have created at, which had its own custom resolver, and that's, we just get it from the object and return it in this case. Yeah, I think that's it. Anyone have any questions?
Twitch chat, nothing.
Okay.
Cool. Thank you guys. Yeah. The slides will be posted in Workplace later, so you can go check out all the links we put in there. We will also update you in Workplace about the source code once it's getting posted.
Thank you, guys. All right, everyone. Thanks for coming to the meeting. Have a good one. Next week, last week, get your e-board nominations in. Check out RIT-CTF. Anything else? Be awesome, I guess. All right, peace out.